Here's another way to work distance, rate, time problems, is if you just draw a box and you have like your rate and then your time and your distance, because, you know, distance equals rate times time. So you sort of write it in columns like this. And then you're going to divide this bigger box into two, because you'd have your, you know, distance up and your distance down, right? So you're, in our river problem, we had the up things that were going on in the down. The rate for this one we said was 22 because it was 20 plus the rate of the river. And then this one was 20 minus rate of the river, or 18. The time, this time plus that time totaled 15 minutes. So we could solve, you know, for T1 and say that it was 15 minus T2. And that way everything's expressed in the same way. Something else you can do up here is just to assign x to be the time. And so, you know, you have 15 minus x is the time up there. And this time is just unknown. And then because rate times time equals distance, you can say that distance is this equation, and that down here, distance is that equation. So what you can do is, since the distances are equal, you just set each equation equal to each other and solve for x. It cuts out some of the middle work for you, so you end up with let's just do this longhand. I was trying to find a calculator, but we'll just do it this way. Okay, so we have 330 minus 22x equals 18x. So 330 equals 40x, and again I just added 22x to both sides. You divide both sides by 40, and x equals 8.25 minutes, because again, you know, the x is in the time box, so we know that this is minutes. So that means distance up, which is what we were trying to find, we can just plug in the 8.25 up there and solve to find that that equals 170.5 kilometers. And I'll let you do the algebra legwork there, but this is just another way to work the same type of problem.